So this video deals with probability of finding the type 1 error. Now to understand what is a type 1 error, we need to understand, you need to think of, I'm just giving you a simple example. It can be any distribution. It can be a normal distribution, it can be Poisson distribution, it can be binomial distribution or any other distribution. Basically, the whole idea of hypothesis testing is you decide a boundary region called the critical value, correct? If it goes beyond the critical value, you reject your H naught. Otherwise, you accept your H naught. Now, how do you decide that? You look at samples. So you're working with a sample. So your first thing is you decide what's your H naught and what's your H1. You decide your significance level, and then you work with the samples to get a sample mean and compare that with this critical value. And then you take a decision. Sometimes what happens is the sample comes out in such a way that the sample mean falls in the critical value. So in spite of your hypothesis being correct, you reject it because your sample doesn't support it. So that's your type 1 error. So probability of type 1 error when you're finding is you have to reject H naught, the probability of rejecting H naught given that your H naught is true. So it was true and you rejected it because your sample didn't support it. So this is the probability of type 1 error. So now I have collected sums of different type. So first one is normal distribution when the significance level is given. Second is when the critical region is given. So this is your two-tailed and this is your one-tailed. I've taken example of both, right? Binomial distribution, obviously I've taken one-tailed only, but the same thing can apply for two-tailed as well. Poisson also, I've taken one-tailed, but two-tailed also. Two-tailed means, rejection region is on both the sides. One-tail is the rejection region on one side. So when the significance level is given, then it's the simplest type, then your probability of type 1 error is simply your significance level. So in this case, my significance level is going to be 10%, so it's 0.1. Simplest form, correct? So you don't have to worry at all. The second type is normal distribution when the critical region is given. So they've given you the critical region. So what you need to do is, when your X is less than 77, you have to reject it. This is your sample mean. So if you're working with a sample of size 20, if it comes that less than 77, you reject it, or if it comes greater than 83, you reject it. Correct? So probability of type 1 error here will be probability that it writes in the rejection region. So that means your X bar is less than 77 or your sample mean is greater than 83. Given that, you have to assume that your sample mean is correct. Given that your mu was 80. So what we can do is, so we have to use NCD for this and get this. So let me help you with the process. So if I'm using a Casio calculator, so you go to distribution, obviously statistics distribution, normal distribution, you go to NCD, your low limit. I'm putting low limit as 77. I'm putting upper limit as 83. I'm finding the right region and then I'll do 1 minus that. It will be easier for me. So lower I'm putting 77, upper I'm putting 83. Standard deviation now. This is very important. Since you're working with samples, you will be using the central limit theorem. The central limit theorem says that X bar follows a normal distribution with mean as mu and the variance is sigma square over n. So in your calculator, your standard deviation you'll be putting is the standard deviation which is given. So 9 square is the variance. So standard deviation is 9 divided by root of the sample size. So you'll be putting 9 divided by root of 20. So 2.0124, that's what I'm getting. I'm saying it out loud so that you can know. So very important. Or you can do what, your variance of the population is 9 square. So the variance of the sample would be 9 square upon the sample size 20. Therefore, the standard deviation would be root 9 square over 20. So that's 9 over root 20. That's the logic if you want to understand, or directly put in 9 by root 20. Don't forget this. This is where children will make mistake and you have to be careful of that. Mean, you have to take mean as 80 because you have to take the population mean is correct. You get that value? So your answer will be 1 minus that because you're looking at the reject region. So 8, 6, 4. So that will become 1, 3, 6. So that's your answer. Alternatively, you can find out less than 77, greater than 83. Now, also this is continuous, so it won't matter in normal distribution whether you have to take 77, 83 only. You don't have to take 76 and 84 and that. That you need to do for Poisson and all that. So that's how you do the type 1 error for normal distribution when the critical region is given. Okay, so basically you find out the probability of the sample lying in the rejection, and since you're working with sample, you have to scale your standard deviation. You have to make it smaller because your sample is smaller than the population. Simple as that. You divide the standard deviation by the root n. So don't forget that. Again, now let's do a one-tail test with this. So when you're doing a one-tail test, so again we have a normal distribution which is there. Correct? Your sample size is 6. Your mean is 7.1. And your critical region is x is greater than 8. X bar is greater than 8. So this is your 8. Correct? Yeah, this is 7.1. So greater than 8. Since it's a normal distribution, it won't matter. So probability of type 1 error is the probability that your sample mean is greater than 8, given that the mean is h naught is true. Right? So again, so I'm saying out what I'm putting in the NCD, lower limit 8, upper limit 10 is to 10. You can put in that very large value, 10 is to 10. Standard deviation, so your variance is 1.2 square. So standard deviation will be 1.2 divided by square root of 6. Again, central limit theorem. We are working with samples. Mean, you take the mean to be correct, 7.1. Yes, so 0.0331. That's your answer. Fine. Now, how do you apply this for binomial distribution? Now, in binomial distribution, you cannot sketch a bell-shaped curve. So what you can do is you can draw a box. I personally draw a box to demarcate the critical region and that region. So number of tiles are 15. Your critical region is when you get the number of tiles less than equal to 9. So if this is 0, this is 15. So when you get less than 9, less than 9. So less than 9. So when I say less than 9, what you need to remember? You have to take less than equal to 8 because this is discrete. So you find a probability of type 1 error in this case by saying probability that your x is less than equal to 8, given that your p is equal to 0.8. So you take your calculator, you go to distribution, binomial distribution, you'll do BCD. We're using BCD, correct? BCD, it's a variable. Lower limit, I'll take my lower limit as 8, upper limit as, sorry, lower limit is 0, upper limit is 8, 0, upper limit is 8, correct? And number of trials, you'll take 15, correct? And probability of success, you take 0.8. Hmm? So you will get this answer as 0.0181. So let me repeat. You took your lower as 0, number of trials is 15 you took, and your probability of success is 0.8. You find, so be careful. Here you can't take 9. You have to take 8 because you have less than 9. So remember that binomial distribution is a discrete distribution. So you draw a box so that you don't make a mistake, and Poisson also discrete. In normal distribution is continuous. Now again, you draw a box over here. Your critical region is x is greater than equal to 5. I have deliberately taking this example when it's greater than equal to 5. So your probability of type 1 error will be probability that your x is greater than equal to 5, given that lambda is equal to 2. That's it. So you put in the calculator. So distribution, Poisson distribution, TCD, lower 5, upper 10 is to 10, lambda is 2. So you get 0.0527. Now, this can also come with double tail test. So obviously you find a rejection region on both the sides and add them. That can also happen. So I've not shown that example, but this is all in all that you need to remember for your type 1 error. Okay, thank you.